Very good. Thank you very much. Good news is I'm last. Bad news is it's a 2-hour-long presentation. Just joking. But how do we... Oh, here we go. Hang on a sec. I think we just go to the next. That's me without the beard. You might recognize me. Some of you will know me. We're now part of Excelitas Technologies, which is a big photonics company. And a brief history of the LED and LED light sources and digital light sources, and I'll get to the conclusion at the end. So the history of the innovation of LED light emitting diodes dates back a lot longer than probably a lot of people think. We think it's quite a modern phenomena, but it actually, from the earliest days of the wireless technology, a time when little was understood about semiconductors themselves, and even less about the possibility of using them to generate lights. So they've been available since the 1960s, and the early LED history, the first recorded effects of the light-emitting diode effect were noticed back in the beginning of the 20th century. So it's quite interesting, a long way ago. So at the very time radio detectors were one of the major limiting factors within the early wireless radio set, so H.J. Round was working for Marconi, and he said the early detectors were often made using crystals of what now we would call semiconductors. A thin wire was placed on the surface and a point of contact diode was made. This was called the cat's whiskers for obvious reasons. So Captain H.J. Round was one of the first early LED pioneers and the first person to notice the LED effect. So there's a typical cat's whisker that was used in early radios. Oh, here we go. They're trying to investigate the effect. So what he saw was Round had passed the current through some of the detectors. He noted that one of them emitted light where the current was passed through it, although he didn't really understand why that happened. So there's his original patent application. I'm not going to read it all out, but he was definitely onto something, but it took a long time. So LED investigations also went on in the 1920s in Russia by Losov. So the LED, it shows that the idea remained dormant for many years. Its invention and use was still a number of years away. And then it was observed again by a Russian engineer named Oleg Vladimirovich Losov. He was the son of a Russian Imperial Army officer, born into a noble family. He attended a number of university lectures, but never took any formal education. But he was a technician. Losov made some major advances. As a result of his observations and investigation, Losov published a number of papers in the technical press, and Losov went to investigate further ideas associated with the diode and what could be later called semiconductor technology. Sadly, though, he was killed during the siege of Leningrad during the Second World War. So in terms of a commercial history of LEDs, the first commercial of LEDs started to appear in the 1960s. The early versions using gallium, arsenic, phosphorus, gas technology, as it was called then. 62 is a busy year with a number of companies reporting infrared devices. The first, in August 1962, Bard and Pittman filed a patent entitled Semiconductor Radiant Diode, and this was probably the first LED light-emitting diode, albeit only providing infrared emission. However, the quest was still on to produce LEDs that gave visible light, and that was achieved by J.W. Allen and R.J. Cherry in Baldock in the UK. This work was reported in the Journal of Physics and Chemistry in Solid, and another major step forward was taken by Nick Holonyak, Jr., who in 1960 invented an LED that could produce visible red light. So that's when we really start to see light-emitting diodes, and as well he was with General Electric. So, but our the first companies to manufacture LEDs on any scale was Monsanto, who we probably know for other things now. So that can be supplying raw semiconductor materials aimed at working with Hewlett-Packard. So this didn't work out. Monsanto ended up developing and manufacturing the LEDs themselves. The name of Monsanto is not seen today. The business was sold in '79 to General Electric. Then in '64, IBM started to use LEDs on computer boards. This was probably the first time printed circuit board assemblies had LEDs incorporated in them. '68, Hewlett-Packard launched its calculators, '71, the production of colored LEDs, apart from red, had been an issue, and Edward Miller and Jacques Pankov developed a blue LED. And then in physics, in 1993, the Japanese really drove the development of the blue LED. And from our point of view, as a UV LED lamp supplier, very grateful them for having done that. It was about 9 years later, we started to develop the first UV LED light sources. And it was all based on this technology that came out of that. So it's just kind of a brief history to just, some technologies take a long, long, long time to evolve, although the nascent ideas are there in the 1900s, and we end up really until the 1993 before we actually get to UV diodes. So if we look at, and why are digital lamps important, right? Because I consider the UV LED light source a digital light source. So why is that important? So as a result of all that pioneering work and so many people, we're now able to benefit from this significant advances in LED technology. So we see applications of domestic and industrial lighting. We're all getting very familiar with automotive and transport lighting, so we see it on airport runways, we see it on the side of trains, trucks, cars, airplanes, all using LED lighting. Industrial curing, we're now seeing lots and lots of systems using LED for printing, but also for coatings and adhesives. We have large customers like IKEA who are curing the coatings on their furniture using our light sources. iPhones are being assembled in China using our light sources to assemble the screens and displays. So LED lighting achieves useful energy savings, 50 to 70% compared to the old technologies. Compared to the old technologies, a global switch to energy-efficient LED technology could save over 1,400 million tons of CO2 and avoid the construction of over 1,250 power stations. Guy, I'm going to have to work out the Tesla analogy, how many Teslas that is for you. So it can show you how a simple change in technology can have a major impact on our businesses, on our environment, on our and many other things. So when we look at the factory of the future, and we heard today as well, Sean, you were talking about the shorter print runs. And about so the important there is, if we look at a digital technology, it's instant on-off. So it's a technology that fits very neatly into that gap and is copacetic with that. So if we look at UV LED lights, digital lamps, can be part of the suite of technologies that enables the advanced factories of the future. I gave a presentation at the end of last year about the factory of the future, about dark factories, and about factories that had very few people within them. And so to move towards that direction, we need to embrace things like Industry 4.0. Intelligent light sources allow us to do things like predictive maintenance, to get them within the system of the whole process. Advanced communications and data acquisition are very much part of that. Part of reactive versus generative AI, so we can start to use artificial intelligence in interpreting the information. We have somewhere in the region of 2 million hours worth of product life testing. So that's information that's very useful to something like AI to interpret that information in terms of temperature, in terms of usage conditions, in terms of environment that the light sources are working in to generate models in terms of predictive maintenance. That gives a greater source of process control and monitoring to help to mitigate some of the skill shortages. So that's another thing that we're seeing, which is very important for our industry, is that we're seeing a dearth of skills available. Young people are not coming into the print industry, and that's a difficulty. So one way of mitigating towards that is having systems that are more intuitive and less operator dependent. So we can work towards systems incorporating technologies like ours and many other technologies within systems that allow people to be less hands-on or less de-skilling to some extent. And then the other important thing is highly energy efficient systems generate better operating economics, that's for sure, and we all know that. And our systems can be anywhere from 50 to 80%. And digital lamps are a better fit for digital systems. So if you're looking at a digital inkjet printing platform, there are very few of them now that don't incorporate LED technology, certainly for UV. Digital lamps are a better fit with digital systems, enabling the optimization of processes to suit flexible manufacturing. And that's it. Thank you.